day 742 off the grid. And in yesterday's video, where I showed how quiet my generator was and said everything's going really well with the Sportsman Pro, well, that was bullshit, really. Because here's the Sportsman's Pro here. Well, the Sportsman Edition 3 Bank Pro. Here's the top of the case. Here's the guts. When I first connected it up, it appeared to be going fine. The generator was running. 10 amps was going into the batteries. It was all hunky-dory. But when I came out a couple of hours later, this was really hot and only 2 amps was going into the batteries. And I tried to do a few tests and changing things around and stuff, but it all pointed back to the fact that there's a fault in this unit. So maybe I was slightly stiffed on Trade Me and someone sent me something which was on the way out rather than fully working. Of course, in my initial tests that I didn't run for very long, it all seemed to be perfectly okay. But this was getting stinking hot. You know, that actual stinking hot, that transformer smell. I can still smell it out here now. But the biggest issue I have with this thing is it's an American-made unit. And one of the reasons why I decided to take a punt and buy this was because I went to the website of the manufacturer, who was that there, Charging Systems International, and they were raving on about how this had replaceable parts in it, and if it failed it could be fixed and you wouldn't have to just throw it away, you know, the kind of stuff. If you're a bit of a DIYer like myself, you go, yeah, hey, that could be really good. A charger that's not a complex board of switch mode power supply that one FUT component pretty much renders the whole thing unfixable. And of course it's got heavy iron core transformers and all that. But I get it here, have this problem, and then think, well, I'll open it up and see if I can fix it. Guess what? No screws. No screws. The buggers had used silicone sealant to glue this plastic top piece, which is this bit here. Let's put it back on just to, I can't actually, got some wires moved, but you know. It's basically built on an aluminium chassis, and then they've just siliconed this top bit off. And you try and remove silicone, hey, whoa, very, very difficult indeed. And I've hacked this top bit off there, you know. The other bit there, it's just stuck on, you know. I mean, what the fuck, you know, they say this, oh, it's fixable. Well, how do you fix something if you can't even get into it? So here I am, using all manner of machinery. I mean, a saw, a hacksaw, a bloody well hammer, and a cold chisel, a screwdriver, and a couple of knives to crack this thing open like a cheap wall wart. You know? I mean, this is an expensive, purpose-made battery charger. It's not just a little wall wart, is it? You know? But here I am, just cracking it open like one of those, as you do when you want to harvest a transformer or something. So, yeah, not very happy about that. But I've got it open now, and there's a few things that aren't that great either. Look, this is their cable clamping. A couple of cable ties around the cable as it goes out. Well, that's acceptable on homemade stuff. Well, it's not really. But on a commercial unit, same with the AC cable coming in here. A couple of cable ties around it. For fuck's sake, what is this? They actually make things better in China. And obviously, you know, getting to the boards is not going to be easy either, because this heatsink appears to be welded as part of the case, which is probably good for heat transfer, but to get these boards out, you've got to drill out these pop rivets. I mean, Jesus Christ. You know, not very impressed at all. What I suspected is that one of these circuits, there's 3 individual circuits there, and they are completely separate. That's why they have 3 separate mains transformers, which is, you know, is the simple but brutal way to get true isolation. And it does work. One of these is faulty, I reckon. Now, maybe I can fix it, maybe I can't, but the simplest thing to do would be, if one is faulty, I can isolate the faulty one and just use the 2 other channels, which will be enough for my needs. So that's probably the quickest and dirtiest way to avoid having to buy something else. So I'm going to go off and do that now, see if it's possible. And here's the charger running. After ripping it open, I've basically investigated the fault. Let's get rid of that bit of grass there. I've investigated the fault and pretty much found that it's running as it intended. So did I hack it open for nothing? No, because if I hadn't hacked it open, I wouldn't have been able to get to these primaries to compare the input currents, and I wouldn't have been able to get to these secondaries to check out what was going on there. The current coming out of the transformer, which is this one being used at the moment, is pretty similar to the current going into the battery. So what do we got here? 6.7 or 6.8. Let's be generous and call that 7. And let's be generous and call that 14. 14 times 7. 7 times 10 is 70. 7 times 4 is 28. So that's 98 watts is going into the battery. And that's being slightly generous. How much power is being pulled from the mains input? Oh look, it's 170 watts. That's not really acceptable for running off a generator, charging a battery on a cloudy day. You want to get as many of those watts from the main side into the batteries as possible. This thing is extremely inefficient. And furthermore, opening it up has allowed me to have a look at the transformers, and these are tiny. I've got a homemade battery charger that's done me all winter with a transformer about twice the size of this, and it gets quite warm, delivering 12 amps or so. This is starting to get quite warm. I can leave my hand on it, but it's pretty cozy, delivering a paltry 6.7, 6.8 amps. Imagine the heat build up when you got 3 of these going like that. Shocking. On another thing, there's a packet of silica gel permanently siliconed in there onto the heatsink. What a great idea. Absorbs the moisture, and then the heat from the heatsink dries it out. Well, that's why sometimes these windows get fogged up, because it just keeps absorbing the moisture and drying it back out into the unit. There's no airflow inside there. When this is siliconed on, there's no airflow in there whatsoever. So yeah, I'm glad I hacked this off. In fact, I probably won't be putting this back on. I reckon I want to build up a sort of a cage around that so that it's ventilated. But I won't be using it for the A-bank from the generator, because it's just not efficient enough, for one thing, but the other thing is it's not grunty enough. I mean, that was a pretty flat battery. That was one I've put on here straight after doing those load tests on it, and it's 6.8 amps. I mean, I want an excess of 10 amps going into my battery. I'm ideally like about 15, because I want room on the generator for running some other direct loads like the computers and stuff like that. So I don't want to use its full capacity on charging one battery bank. But yeah, 10 to 15 amps. Oh, and one final thing that makes this unsuitable for my needs in this situation is that this is completely linear. There is no real regulation going on, so the output current is actually highly dependent on the line input voltage, which on a generator, that's not the best thing. And my generator is actually a little bit high. I've found no way of controlling the voltage. It's a little bit high. And of course that means even more current flows, which is good, but it means more heat is produced in this, which makes these get even hotter. That is getting quite warm now. I can still leave my hand on there, but only just. I suppose I could just deal with that and maybe build a fan force system around it, but it's just not that efficient, is it? It's just not that efficient. Those transformers aren't really big enough. Not really big enough to do the job. Which is a pity, because the regulation system seems to work pretty well. But this is definitely either just put it aside and just, I don't know, sell it, give it to someone, I don't know. I mean, it'd be fine if you're using it for its original intended purpose, which is probably charging up a golf cart where you don't mind the inefficiencies. One thing I was worried about is I thought that maybe being an American unit, it didn't actually have 230 volt transformers in it, but of course opening it up, it allowed me to see, there we go. 230 volts, and it's 26 volts centre tapped on the secondary side. 26 volts centre tapped. That only means 13 volts AC aside under its rated load, which it doesn't say what the rated load is of these, but they can't be 10 amps. So why this charge controller is being sold as 10 amps per channel when that's not a 10 amp transformer? But yeah, 26 volt centre tap, that's only 13 volts. So of course, being AC, of course, you get the peak, which is significantly higher, but that's what they're relying on in this to limit the charge current, which is, of course, dependent on the line voltage. That's so old school. I think what I really need is a switch mode. Or I could just go back to my original scheme of stacking up those little blue auto house ones from the warehouse, although that's an expensive way to go. But they have proven to be robust and reliable and quite useful. So we'll see what happens. But yeah, the Sportsman 3 Bank Pro is the main battery charger for my A bank on the little generator. Don't think so. Alright, as a fitting way to wind up this video, I've pulled out a couple of the little Auto House blue chargers and I've got them both pumping into this battery together. That's giving us a combined current of 7.5 amps and 13.78 volts. Now, without being generous and using those exact figures, that combines together to make a total of 103 watts. And we're not being generous there. We're not going, this is 14 and this is 8. That's 103 watts. And what's the input power? 126 watts. Far more efficient. Far more efficient. Another one of these and I'd be over my 10 amps, which was my original idea, to build up basically a cluster of these, a bank of these, a battery of battery chargers even. And the advantage of doing that, although it's a little bit pricey, you can do it over time, and you're also buying brand new products. You're not buying someone else's rubbish from Trade Me. Not that I think there was anything actually wrong with this now after putting it through these tests, but the problems with this are in the design itself. It does have some problems, but they're not caused by the last owner of it. They are caused by the very design of the unit, which, if I use it for any further purpose, I'm going to somewhat rectify. But yeah, little cheap switch mode chargers. Well, they're not that cheap really. They used to be $49, but I was waiting for a sale, and while I was waiting for a sale, they went up to bloody well $59, didn't they? And I haven't seen them on sale again. Maybe I should grab some more when they are. And you can go to any warehouse and pick one up. Yeah. Again, 126 watts from the mains. When I say the mains, of course, around here, that's an inverter. That's the Latronics inverter in this case, because there is no grid. It's just... But I use the term mains to describe usually a 230 volt circuit. Sometimes I might consider the 120 volt circuit mains, but usually it's the 230 volt circuits which I consider mains, which is the normal New Zealand mains. Any other voltage is not really New Zealand mains as such. But yeah, I'm quite pleased with these little chargers really, and I'm not so pleased with the 3 Bank Pro. But you know, that's what you get when you're off the grid, isn't it? On day 742.